Kyle, can you hear me?
Yes, ma'am.
रोहित जी, कायले लिली ने ज्वाइन किया है। आप प्लीज उन्हें को होस्ट बना दीजिए।
That's okay.
Hi, good evening. I can speak now.
हाय कायले, गुड इवनिंग।
Good evening.
हाय, हाउ आर यू?
Doing well. How are you today?
आई एम आल्सो गुड। वुड यू लाइक टू शेयर योर प्रेजेंटेशन?
Yes. Okay.
वी शैल स्टार्ट इन 5 minutes। लेट ऑल द पार्टिसिपेंट्स ज्वाइन।
Okay, very good.
शर्मा से स्टार्ट करें सेशन।
Yes, madam. Yes, please.
जी। सईदा प्लीज स्टार्ट द सेशन।
All right, ma'am. Good evening, everyone. On behalf of the Agriculture Valley Research Foundation and Agri Meat Foundation Bharat, we extend a very warm welcome to all the distinguished participants, researchers, academicians, students, and science enthusiasts joining us from different parts of India and around the world. I'm Sedanal Zahra, Technical Secretary to the founder AWRF, and we are delighted to have you with us for today's special session under the Ankaran and Krishi Navyug initiative. Today's session is really exciting as we are joined by an industry leader whose work has helped transform scientific research into practical solutions and modern agriculture. It is my great privilege to introduce our esteemed speaker, Mr. Kai Lilly. Mr. Lilly is the Chief Science Officer at the Custom Biosciences and founder of Lilly Ag Consulting, a specialized advisory firm that provides technical and business consulting services to growers, organizations in agriculture and environmental sectors. A soil scientist and accomplished agricultural product development leader, Mr. Lilly brings over 15 years of experience in developing and commercializing value added agriculture technologies. Throughout his career, he has successfully launched and developed dozens of specialty biological products across the United States and international markets, making significant contributions to sustainable agricultural practices. What makes his journey especially remarkable is his unique blend of expertise in chemistry, agriculture, business, and management. As Mr. Lilly is widely recognized for his expertise in fertilizers, fertilizer additives, biostimulants, biological products, and soil fertility. At the heart of his work lies a deep passion for soil science, sustainable agriculture, and environmental stewardship, with a strong commitment to helping growers solve real world challenges through innovation and practical solutions. We are truly honored to have someone with such extensive industry experience and global perspective with us today. I am confident that his insights will inspire all of us and provide valuable lessons on innovation, leadership, and the future of sustainable agriculture. Now, without any further ado, ladies and gentlemen, please join me in extending a warm virtual welcome to Mr. Kai Lilly. Mr. Lilly, it is a true pleasure to have you with us today. Now, if you would, the virtual stage is all yours now. Thank you.
Thank you very much for that nice introduction and glad to be here. It is very early in the morning where I am from, but I'm pleased to share my expertise on the topic at hand today and share my point of view, mostly from the US market, where I've spent most of my career, but also have spent a significant amount of time working in international markets as well. I am born and raised in Southwest Iowa in a small town called Glenwood in the southwest corner, a very rural area. It's also one of the best places in the world to go to grow cereal crops, particularly corn and soybeans, the main crops that are grown in this Missouri River Valley that has some of the best and deepest topsoil in the world and some of the most productive corn acres. So Iowa's known worldwide as one of the best places to grow corn. And I now live in Minneapolis, Minnesota, a short drive north, where, as was mentioned in the intro, I just recently left my job for a ag distribution company to start my own businesses. I have a manufacturing business called Custom Biosciences, where my partners and I manufacture custom built to order fertilizers and biostimulants for customers around the world, and my own consulting service called Lilly Ag Consulting, where I help with unique agricultural challenges in this niche where I kind of bring technical knowledge to the real world applications. So, as I'm giving a presentation today, this can be fairly informal. If you have any questions as they come up, feel free to interrupt me or add the questions to the chat. I'd be happy to address anything as it comes up during the presentation. So the topics today are talking about traditional and newer fertilization approaches. So seeing how some of the techniques in the new innovation have changed the way we analyze our crops and soils and make different management practices. We'll talk about some established fertilizer technologies that maybe 30 years ago were considered new, but now have been well established. And then I'll talk about some newer fertilizer and plant growth technologies, including, including biostimulants and some of the more commonly used biostimulants in North America. And I'll spend quite a bit of time on microbials as those have had a renaissance here in the United States and are quickly becoming heavily used across the country. And then finally talk about some fertilizer and biostimulant innovation, some new research that's come out, and some of the interesting applications I've found. So, when I'm going to farmers around the country or the people who sell inputs to farmers, one of the first things I ask them is if they do a soil test. And believe it or not, some farmers in the US still don't soil test. So the very first thing before we can get into the fancy innovations and the new exciting research is to make sure that farmers go out and do a soil test so they know what is in their soil and what their crops have the potential to take up so the crop can meet its need to grow and meet its yield potential. So the basic farmer will add nutrition to meet the soil test recommendations. It's a sufficiency approach. So basically a mass balance, what you take out in the grain or the fruit or the harvest has to be replaced with what we put back in the soil. So this is just a simple mass balance correcting for deficiencies. Now the next step up, if a grower is doing that, would be generally to look at what's going in the plant. And this can be basically the next level of, all right, what's your efficiency? If you look at cows, right? I like to use this story. If you have, a bunch of cows and they're in a pasture and the gates open, the best thing to do is not to buy more cows or feed your cows more. The best thing to do is to close the gate. So if you're fertilizing your plant and you're noticing that your plants aren't growing as you expect, a tissue test can really help see what's going on. And you might need to close the gate if your fertilizers are all getting lost um, through environmental losses like runoff, leaching, volatilization, those types of things. So the next stage of grower is someone who will look at the nutrient levels in the plant and look at the uptake levels by growth stage. So it's really interesting. What I've found in some of the genetics are that not only are more crops being taken off the field with higher yields, some of these crops are taking up more micronutrients um, per bushel of grain or per unit of grain. So we found in corn rootworm resistant varieties of corn, they actually need more zinc than 50, 60 years ago because the genetics are predispositioned to take up more zinc per unit of grain. So that's kind of interesting. Also, helping to line up the fertilizer application with when the crop actually needs the fertilizer. Take corn, for example, when the corn reaches the sixth collar stage, the V vegetative sixth stage, it generally needs more nitrogen and also potassium and other nutrients so it can build that energy factory and eventually put more nutrients into the grain. So we would recommend applying most of the fertilizer and the nutrition right at that vegetative sixth stage there. But the downside for some of these traditional approaches are a lot of the fertilizer applications are not responsive. So from Iowa State University, only 1/3 of 240 trials responded to broadcast phosphorus applications. So we're still recommending to growers to apply phosphorus to meet their crop needs and to meet that sufficiency recommendations, but not every year does it always work out. Same thing with potassium broadcast. Only a quarter of 2,100 trials responded to broadcast. So you might be building up that level in the soil, but the crop doesn't always respond. And I think I mentioned that zinc uh, level earlier here. So, what can we do to see my screen's blocked here. What can we do to improve this? And what's going on here? Well, not all fertilizers are equal. Some fertilizers have a greater potential for losses. High rates of fertilizer can decrease yield, so sometimes the fertilizer might be applied too high and it can actually burn the crop root if it has too high of a salt level. And plants do not take up all their fertilizer at once. So some farmers apply all of their fertilizer for the whole season before the crop's even sowed in the ground. And fertilizer can be lost from your field into the environment, which can be a big issue. And I'll share some of why that's a big issue in the later slides here. But this in the United States, you might want to look it up. It's very interesting. We have a fertilizer, I'll call it lobbying group, but also just the group of the fertilizer industry is called the Fertilizer Institute, and they have a 4R framework that focuses on the right source, the right rate, the right time, and the right place for applying fertilizers to the crop. So thinking about this is kind of an intermediate level of how I work with farmers and help them improve their fertilizer efficiency. So the goal is to spend less money on fertilizer, get more out of that fertilizer, and in turn, the the farmer will get a higher yield and profitability from their field, and the environment will have less negative effects from the loss of that fertilizer into the field. So this approach will get you a decent crop, but is it profitable and sustainable? So um, my challenge today is, can we improve from this framework and make it even better based on some new technologies in agriculture that have really started to commercialize and take off in the past even just 5, 10 years. So this is my grandfather. It's his favorite photo right here, actually. This is him when he was 14 years old, standing on a McCormick Deering tractor in 1942. So this was one of the um, big innovations in 1942, this style of tractor. And then we see my uncle and my grandmother here spraying for beans. They would sit on the front of the tractor and spray with a hand sprayer. Nobody does that anymore in the U.S. on soybeans. Um, and then here's my cousin Kurt planting in 2017. And then today, my cousin has auto steering and GPS and all kinds of innovations in agriculture. So a lot of people tell me, oh, farmers, they're resistant to change, they're not embracing new technology, but we see we see farmers really, really embracing technology and really interested in using that technology to improve their farm, because if they don't, they've seen a lot of their neighbors go out of business. So why is it important for agriculture to adopt new fertilizer technologies? Well, I believe the big reason is that globally fertilizers are only 50% efficient. So, like I mentioned, with having cows in the pasture, if that gate's open, we got to do something about losing up to 50% of our fertilizer that we apply. So this is a blue-green algal bloom. We have these in Minnesota as well from eutrophication or nutrient runoff into water bodies. Um, and if you look up right now, there's actually a big issue in Washington, D.C. in the reflecting pool with algae taking over and making that pool green. So anytime you have warm temperatures and a food source in a stagnant water body, uh, very, very likely you'll see algae coming over, and that creates a lot of problems because it can take oxygen out of the water and have a big effect on our wildlife populations, particularly fish, and everything runs up from there of the things that eat the fish. So in my home state, this is basically the state newspaper, Des Moines Register. Um, the city of Des Moines Water Works sued three agricultural counties for polluting the Des Moines River, and the Des Moines River runs through Des Moines, and the city gets their water from that river, and so they had to spend millions of dollars on a nitrate reduction system. So the nitrates the city's claiming is coming from the farmers' runoff from the anhydrous ammonia and the nitrogen fertilizers they're applying and the hog manure. And coupled with the tile drainage, they're trying to prove that the farming community should have to pay for it. So the farmers are feeling unfairly targeted. So the public, of course, here has their needs. They want cheap food and clean water, and farmers, feel like they're getting teamed up against. The good news is that agricultural production continues to improve, but fertilizers need to keep up. So you can see here, this is USDA corn grain yields over the past 160 years or so. And it was basically flat until something happened here around 1935, 1940, the invention of double cross hybrids. And we saw a pretty big response from there. And then after that, we saw this basically green revolution kick in with genetics, fertilizer, pesticide, and mechanization happening. And we're seeing things start to taper off, but we're also seeing new innovations coming just in the past couple of years that are really exciting. So our opportunity is the yield gap. And as I mentioned, in the US, corn and soybeans are the two main crops, followed closely by wheat. Our national average, and this is old now, I need to update this, but our national corn average is about 175 bushels per acre, and the individual who grew the highest corn yield, I believe, might be Randy Dowdy out of the Southeast United States. He grew almost 545 bushels of corn. So that's showing it is possible to grow much, much more corn per acre. And the same thing with soybeans. It's possible to grow much, much more. But we have contributing factors that uh, affect this yield gap, right? So every farmer knows that weather, especially not getting enough water, can contribute to this yield gap, but also genetics, soil health, and pests. So I'm going to put a big emphasis today, this presentation, on soil health and fertility and how that can help bridge this yield gap and improve the way we grow our crops and improve that efficiency and help us grow more crops uh, with a more efficient approach. So I'm proposing a technical revolution in plant nutrition, not simply applying the sufficiency approach of applying nitrogen, phosphorus, and potassium with all the um, inefficiencies built in. So I asked my farmers, how much do you spend on fertilizer in the last year? And some of these farmers, they're literally spending 100,000 US dollars a year, which is more than a lot of families earn in a year just on fertilizer and in the last decade. And imagine if 50% of that was simply wasted. It's just a lot of money. So the new approach is really summarized by this chart, and I'll go into a lot more details, but it's applying plant available fertilizer and using biostimulants to match plant growth cycles and upcoming stresses. So plants need, as we know, they need certain total amounts of nutrition to grow to their yield potential. So they have to take up nutrients from the soil and from the water and from the air into their tissues and convert that into protein and move that into the grain or the fruit to meet their needs. So that's level one. Number two is they need to do it at certain times. So the crop needs most of their nutrition toward the midpoint and later in the season. And then the last part here is they need certain nutrients at certain times, and they have certain physiological functions at certain times. So if you look at germination and establishment, it's a point where a crop is really fragile, kind of like a little baby, right? I had my first baby boy just over 5 years ago, and when he was born, we were so nervous until he got to be about 5 or 6 months old, and then he was big enough that we kind of didn't have that stress anymore, worrying about the baby getting sick or having issues with health. So same thing with the crop. That once the crop comes up, it's a very fragile stage. So whatever we can do to help that, specifically by focusing on cytokinin and some of the cofactors of cytokinin for cell initiation and cell division, and also moving into auxins, that will help the crop get off to a good start and help, especially with cold stress and cool, wet soils we have in some of our spring sowing, and then transition on and on to the next stages to vegetative growth where you see GA3 and flowering and reproduction, where ethylene and abscisic acid play larger roles here. Alrighty, so I'm going to go into some of the kind of more practical aspects of the presentation here now. Existing fertilizer technologies, efficiency technologies, these are typically called enhanced efficiency fertilizers. So three different categories here: slow and controlled release fertilizers, stabilizers, and then phosphate management products. So the slow and controlled release fertilizers are not really used on grain crops. Mostly these are used on lawn, sports turf, nurseries, and greenhouses, really higher value crops. But there are some brands being used on row crops, and one of them is called Coron. That's produced by a company called Helena. It's a urea formaldehyde, so basically urea polymer. And that polymer is very interesting because it lengthens the size of the urea molecule and it slows down its reaction in the soil. And some of it's actually applied on the leaf, so it makes a sticky substance on the leaf and can slowly release into the leaf over time, providing a good source of late season nitrogen. Coke is a large fertilizer company in the United States, and they have some slow release fertilizer in the granular form. Methylene urea is also very common. These products are great for nursery and greenhouse. Many of the products are coated with polymers, so kind of like an eggshell on top of the fertilizer. And these products, once they get wet from the soil moisture, from the rain, and experience some heat, they start to swell up, and they're basically given a time period on the label. It'll say 30-day, 90-day, 180-day release, and that's based on the thickness of the polymer and is a general recommendation of how long that fertilizer will last in the soil based on that polymer coating cracking and breaking down and releasing those nutrients. There's also sulfur. Sulfur is pretty common as a coating, so companies will melt the sulfur and then spray it on top of the fertilizer, and then once it cracks, that breaks down and releases the fertilizer to the crop. So these are really good technologies, especially if you're um, fertilizing a crop and you need to, for practical purposes, get out in the crop before the crop's out, but you don't want the fertilizer to be released until a later time. So there's a product very common in the US called ESN, Environmentally Smart Nitrogen. I believe it's produced by Loveland Products. That's commonly used on corn and soybeans. And that's a polymer coated urea that's starting to be used. So it is promising to see that technology used in the US. Nitrogen stabilizers are very common in the US and are great tools to reduce losses for nitrogen fertilizers. So urease inhibitors are the main category here. So these are effectively blocking the urease enzyme that is found in crop residue in the soil, and especially in damp conditions, we see that urease enzyme having lots of activity, and the nitrogen that's applied to the soil um, will react with that urease enzyme and will volatilize in the form of ammonia into the air. So one thing we can do to reduce that activity is to apply a urease inhibitor, and the most commonly used one in the US by far is NBPT. We have several branded products, Agritane being one, Centuro, um, lots of products on the marketplace that are really helping farmers apply that fertilizer. So I typically tell anybody who's surface broadcast applying a urea fertilizer that they need to use a urease inhibitor. It's a great investment to make sure that fertilizer doesn't immediately get lost to the air. The other big category is a nitrification inhibitor, and this is effectively blocking the conversion of ammonia into nitrate. So nitrosomonas and nitrobacter are involved in that process. The nitrification inhibitor most commonly used in the US are two of them are DCD, diacyldiamide, and nitropyrin. Those are basically bacteriostats that put the bacteria into a state of stasis or basically puts them to sleep and will keep that nitrogen in that ammonia form, that positive charge. And I tell growers that you can think of the soil as a magnet, and the soil's a minus, and you want your fertilizer to be in the plus so it sticks to that soil, and especially in the form of nitrogen. So um, Instinct and there's many products on the marketplace. I think it's Anvil and Instinct are some major brands here in the US that are great nitrification inhibitors. So breaking it down into more nitrogen technologies, we have our controlled release fertilizers that I mentioned. with the polymers and the sulfur. We have stabilized nitrogen. So that would be the MBPT and DCD, as I mentioned. We have slow release nitrogen. So chemical chains like the methylene ureas and so on that I showed. So the big losses with nitrogen is leaching and nitrification. On the phosphate management tools, these are less widely scientifically, I guess, accepted, but they are growing in usage. So a major loss for phosphorus is immobilization in the soil and precipitation with secondary minerals in the soil. So we have very high calcium soils in the United States, so a lot of phosphorus is applied in monoammonium phosphate and diammonium phosphate forms, so that phosphorus is fully water soluble. It gets applied to the soil and it immediately reacts with calcium and forms calcium phosphate, or it reacts with iron and aluminum and forms those same insoluble nutrients and basically becomes unavailable to the crop. So some of these technologies use some polymers that can that will actually bind to the calcium and sequester that calcium, similar to how an EDTA would work. And if you're sequestering at least some of the calcium, it will keep some of the phosphorus available. And it's a great tool to use to actually physically coat the dry fertilizer and to apply it to liquid fertilizers. But it's basically treating the soil to prevent that tie up. All right, so that kind of finishes up the basic technologies here on fertilizers, and we're going to move toward biostimulants. And in the U.S., the U.S. DA just defined biostimulants, I believe just in the last 5 years. But for me, I define biostimulants as active ingredients that improve crop yield and quality by enhancing stress tolerance and recovery, water use efficiency, nutrient use efficiency, and plant growth directly. So this picture of seaweed on the left shows um, some of the stresses that our crops are affected by and what biostimulants can really help with. So I did this trial myself, just grew some wheat in some potting soil, and I stopped watering it. Um, and right after I stopped watering it, I sprayed it with a amino acid biostimulant. And what I noticed is when the crop didn't get any water and started seeing the effects of drought, that crop that had the amino acid applied to it really grew better. So I'll go into why that happened in the next couple slides here. But first, it's important to define the biostimulant terms, right? So in our industry, a lot of people use biological and biostimulant interchangeably, but in the US at least, biologicals include biopesticides as well. So I almost think of this as animal taxonomy. You have different your kingdom, your phylums, your species level. But and then once you get into microbials, you get to the strain level, and the strain is almost like a different breed. So different breeds of dogs. A Chihuahua is different than a Rottweiler, right? They do different things. But back to biopesticide. Biopesticides are very commonly used on fruits and vegetables and nut crops in the United States, and we can even have some non-living biopesticides. I know neem oils very common and is sometimes considered a biopesticide in the United States, as are some pheromones. And then we have quite a few microbial biopesticides, a lot of bacteria that have unique properties and can produce antibiotics that are really interesting. But I will be spending most of my time on biostimulants, microbial and non-living biostimulants. And in the non-living biostimulants, we'll go through hormones, extracts, and synthetics. So once you get into biostimulants, I really like this kind of overlapping diagram here, classifying the different types of biostimulants. Ranging from acids, microbials, and extracts. So you can see, a different way of looking at it. And the issue is nothing's black and white here. A lot of these overlap. So I mentioned amino acids, they fit into acids, obviously, but they also can overlap into this other category, with protein hydrolysates and amino acids being very similar to each other. I've done a lot of research into beneficial elements like silica, aluminum, nickel, cobalt, molybdenum, those types of things that generally are not considered fertilizers. Extracts, seaweed extracts are very common, as are quite a bit of other things in the U.S. like chitin and chitosan. Microbials have had a lot of venture capital funding put into them and are now used on many, many acres in the United States, with rhizobium being very common for nitrogen fixation on soybeans and peas and lentils and legumes, but also very popular more recently or more complex consortia where different microbial strains will be blended together. So you might see fungi and bacteria, mycorrhizae, and bacillus and trichoderma all apply together to meet specific crop growth needs depending on how it's applied and what timing of the crop's growth cycle it's applied. And this shows a lot of the different ways how biostimulants work, but for me, the main summary here is that biostimulants improve stress tolerance and recovery. We have probably our biggest issue in the whole country is with water stress and drought stress when we get our big heat waves, when it gets very hot late in the season, when the crop is flowering and needs to pollinate or fill its grain. A lot of times the appropriate water levels won't be there. So biostimulants are great tools to reduce that negative effect of drought and heat stress late in the year. Nutrient use efficiency, and they can actually, I call it, trick the plant into growing more efficiently and growing bigger and stronger with the use of these plant hormone precursors. So in the US and internationally, the biostimulant market is growing rapidly. They are saying about 11.3% compound annual growth rate. When I started working with biostimulants in 2012, most of the farmers I talked to didn't believe in the products, didn't believe they worked, but some farmers still don't believe that. But by far, the majority of the farmers I work with are currently using biostimulants and are big believers in them and use them year over year, especially the biggest farmers. And you can see here in the US, the microbial biostimulant growth rate by Dunn & Trimmer, a market research company, is growing faster than the world. And what's also exciting is the amount of research done on these products keeps going up every year. So that's very helpful for us in the industry because I read scientific literature every day. So we can learn from that research and incorporate that research into the products and recommendations we are giving to our customers. So on the non-microbial biostimulants, we mainly have amino acids, organic acids like humic and fulvic acids, and seaweed extracts. So amino acids obviously are built from carbon and oxygen from the atmosphere. Hydrogen comes from water and water in the soil pores. And then they form carbohydrates through photosynthesis. So you combine that with nitrogen that the plants get from the soil, and you get amino acids. And the amino acid, is the building block of protein. The main point here is it's a very energy intensive process. So if I can apply an amino acid exogenously or amino acid to the plant leaf or to the plant root, and the plant takes it up directly, it's a lot easier and a lot less energy for that plant to utilize that amino acid rather than building it itself. So I asked my farmers, how would you feel if you had, let's just say, 40% more energy every day? How much more work could you get done? And the same thing is true with the plant. The plant can grow a lot more efficiently if it has amino acids readily available uh, for taking up. So plants have to use amino acids in the L form. They have left hand and right hand basically molecules, chiral molecules. D and L forms. The plants use the L form. So the plant can actually store amino acids and use them when they need them. So if you accidentally applied too much amino acid, the plants can take them up and store them in the leaves and the stem, and then mobilize them during ear development or grain fill or fruiting. Here's an example of glutamic acid, one of my favorite um, amino acids because it's a great nitrogen source and a good precursor to the plant hormone called auxin that helps with um, cell division. So that's very important for plant growth. So glutamic acid, this study was showing how it reshapes the plant microbial community and enriches populations of a good bacteria called Streptomyces. So once the glutamic acid grew that good bacteria out, it was able to outcompete the fusarium fungal disease that harms this tomato crop here. And after foliar application, the streptomyces increased both on the leaves and in the root zone. So a lot of farmers don't really realize that the microbes on the plant leaf are actually very important. So a lot of the pesticides can negatively affect that. So going in after a pesticide spray with the biostimulant can help build back that healthy microbial population on the plant leaf and reduce some of those leaf diseases that we see late in the season in the US. So this also showed that plant-resistant related genes were not activated, suggesting that the glutamic acid directly influences the microbial community rather than activating the plant's genes and protective mechanisms. So this is showing the fusarium wilt here on the FOL and how the glutamic acid showed a bigger, stronger plant, obviously. So you have untreated fusarium, applying the amino acid with the fusarium and then the amino acid by itself. So this example, it's a great opportunity to apply the amino acid during stress and also without stress. Alrighty, so humic and fulvic acids are also very common. They're naturally occurring, already found in your soils, but if we can apply these products, they have very good use. So fulvic acids are commonly used with foliar fertilizers and are very good at helping to shuttle the nutrients into the plant. Humic acids are used in two different ways. One is a soil builder. So some of these products are applied at, say, tons per acre to build the soil as soil amendments, and others are applied at very low use rates, particularly as liquid extracts for a biostimulant effect where they can directly improve plant growth and provide a food source for beneficial microorganisms in the soil. So comparing the two here, fulvic acids are smaller, lightweight molecules, humics are bigger, and because of that, the humic stays mostly in the soil, improves structure and nutrient holding. Fulvic acid can actually go into the plant, and they're used in different ways in different forms. They're granular, powder, water-soluble products, liquids, and a lot of different things that farmers use in the U.S. here. Seaweed extracts. I worked for a company called TMAC Agro. They're a large seaweed extract manufacturer based out of Saint-Malo, France, the western part of France. And they harvest the seaweed from the ocean and chop it up and react it with various reagents and get a lot of beneficial substances that come out of that seaweed extract, and we can apply it to crops and get a lot of benefit, especially in reducing environmental stress like drought and hot weather. So there are, as I mentioned, high levels of plant hormones like auxins, cytokinins, and gibberellins, as well as different oils and carbohydrates and food sources in there. Betaines, particularly, I'll point out, are osmoregulators and really help with drought stress. Most of the seaweed extracts are applied in the U.S. at 1 to 4 quarts per acre or 1 to 4 liters per hectare. And they elicit responses well beyond the product's nutrient values. So across different field trials, Ascophyllum nodosum is the most common, a green seaweed. The extract-based products deliver gains in yield, root biomass, and drought and salinity tolerance. With most of the best responses when you have moderate stress. If there's no stress, we still see results. If there's too much stress, we still see results. But if there's a little bit of stress, we've seen upwards of 20 to 40% yield improvement on fruit crops like melons and apples and things like that. Microbial biostimulants. I made this table to help me think through the different microbial biostimulants on the marketplace. I had mentioned earlier rhizobia. These are industry standard now. They've been used for over 30 years. Farmers put them on their soybeans and they fix nitrogen by forming nodules on the root. So very common in the US. What's growing very quickly now are other diazotrophs, so other microbes that fix nitrogen, that are not bradyrhizobia. So Azotobacter and Azospirillum are either free living, where they live out in the soil, or they form loose relationships with the plant, where they might live in the root zone and go in and out of the plant in that area near the plant. Endophytes have had a lot of interest where there's a lot of species and genera out there, and they live within the cells of the plant. So I'll show in the next couple slides here the mechanism of how some of the nitrogen fixing endophytes work and how they can deliver nutrients into the plant. Bacillus, Streptomyces, as I mentioned, are other bacteria. Mycorrhizal fungi form a symbiosis with the plant roots and basically extend the plant's roots through forming hyphae. And then there's other fungi like trichoderma and penicillium that can really help with other nutrient uptake. So this shows a conceptual diagram of microbial symbiosis. Microbial hyphae here on the right-hand side extend the root zone into the soil, and the hyphae take nutrients from the soil into the roots. So I almost think of this as if somebody is drinking and they're very thirsty, they could drink from a very small straw, like a small coffee straw with maybe a 2 millimeter diameter, and it would take a long time to drink up that water. And that might be an example of a root without the mycorrhizal hyphae. But if you have that hyphae, you can essentially widen that straw to a wide straw. Maybe that's just say 20 millimeters in diameter. So all that surface area adds up, allows the plant not only to take up water, but the nutrients that come with that water. And this is really exciting. This rhizophagy cycle has been known for a number of years, but it has entered mainstream agriculture just recently in the past couple of years. So the process is basically microbes take up nutrients in the soil, and they carry those nutrients within their cell body. The microbes, these endophytic microbes, enter the root like little delivery drivers, and they pass through the root cells and they carry those nutrients inside. And then they basically strip their cell walls um, through a chemical process where the cell walls are stripped down. They uh, basically release those nutrients into the plant. They exit out into the plant root again through this picture here showing them emerging from the plant root hair tip. And they are free of nutrients and they recharge and they go again in this rhizophagy cycle. So through new histochemical techniques, um, Dr. James White and others have shown that plants are directly getting nutrients in the form of nitrate, ammonia, and nitric oxide um, through this rhizophagy cycle. So last thing I have here is some fertilizer and biostimulant real world applications. These researchers from the University of Singapore injected biologicals directly into the plant with a microneedle patch device, so scratching the plant and injecting fertilizer that way. I just thought that was really cool, and it will be interesting to see if that takes off. Something my company does is a dry seed coating on corn, four-component biostimulant stack of microbials, extract biostimulants, fertilizer, and a flow agent. So to lubricate the corn in the farmer's planter, we apply this ingredient, and we've seen very good results by applying all these beneficial ingredients directly to the seed so the plant has access right when it's growing. Um, this is another very interesting topic, metabolomics. So with new spectroscopy and separation analysis, we can see how small molecules change after having different treatments. So this showed that microbial-based biostimulants improve crop productivity by changing the cell metabolic processes and hormonal balances. So plants that were treated with biostimulants had different balance of hormones, and they had higher levels of beneficial metabolites like carotenoids, saponins, and phenolic compounds. So by doing that, we can basically help trick the plants to grow and survive the different stresses and produce more yield. And this is a new one that came out this year where usually in the US when a phosphorus heavy phosphorus fertilizer is used, mycorrhizal populations go down. This team in Germany discovered a way to manipulate an enzyme that would allow microbial colonization even in high phosphorus soil conditions. So this would allow a plant to have traditional mass flow and diffusion uptake of phosphorus, but also that uptake from the mycorrhizal fungi. And this is showing that beneficial nutrient nickel. Almond leaves here showing kind of that mouse ear. So nickel is a cofactor for unlocking nitrogen within the plant. So my company's had a lot of success applying nickel to various crops across the country, anything from strawberries to tomatoes to soybeans to wheat. We've had a lot of good results applying very small amounts of nickel and seeing that improving the nitrogen content of the crop and the yield of the crop. And we've added that nickel with cobalt and molybdenum to provide a nitrogen catalyst and something to help delay senescence in the crop as well. So I will summarize with that. Traditional fertilizer practices are out of date. All the best growers in the country are using these new approaches that utilize nutrient availability by crop growth stage, stress management, and plant hormonal fluctuations using micronutrients and biostimulants as tools. This market is growing rapidly and evolving, and if farmers don't use these technologies, they could get left behind. And some of these innovations are helping tackle major worldwide growing conditional problems like drought and heat stress. And my company is available to develop these types of products and help with these types of issues. If any of you on the call do have any interest in developing a product or testing one of our products in India, feel free to let me know. You can find our company's contact info at custombiosciences.com or just Google Custom Biosciences. That's our company name. But again, thanks for having me today, and I was glad to be here and happy to answer any questions.
Thank you so much for such an interesting presentation. Now, if any participant has any question or doubts, they're welcome to unmute their mics or they can drop the same in the chat box. In the meantime, sir, I would request you to wait 2 minutes as many of our participants actually prefer to write in the chat box.
Kylie, actually, I do have a question for you. Uh, in one of your slide regarding where you are speaking about the microbial biostimulants and where you have spoken about certain bacteria like Pseudomonas and Bacillus, they are like providing certain chelation process for like what sort of process is chelation? Like what is how it is benefiting the plant?
Are you saying chelation?
Yes, 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 exactly.
Okay, yeah, chelate, yes. So, microbes can release metabolites and different. Okay, so take iron for example.
Is it
Iron
something like related to microbial siderophores, which do iron chelation?
siderophores.
Okay,
That's the word I was looking
okay.
for. Yep. So siderophores can help improve iron uptake efficiency. So that's a well-known mechanism that's related to the microbial community.
Okay, thank you so much. We do have
Yep.
question in the chat box. Like Ajay is asking one question. He's saying, first of all, thank you, sir, for the wonderful and insightful session. My question is, what key indicators should farmers regularly monitor to evaluate improvement in soil health, and which of these indicators are most practical for on-farm assessment?
Yeah, that's a great question. So we have uh, we have a test in the United States called the Haney Soil Health Test, and I wonder how it would be internationally. But basically, we're looking at soil microbial respiration. So I can take a sample of soil and put it in a jar and then measure how much carbon dioxide has been pushed out, basically. So that's one level is look at your soil microbial respiration, and that'll tell you how much microbial activity you have, kind of at a qualitative level. And then we have also done just looking at percent organic matter over time. So with the incorporation of organic inputs and cover crops, organic matter can come up over time. And then also carbon to nitrogen ratios. And then we have some less practical, but that are interesting tests that look at the DNA profile of the soil and the relative abundance of different bacteria and fungi in the soil. So yeah, that microbial respiration, carbon to nitrogen ratios, um, and yeah, the soil health DNA tests are pretty interesting.
Thank you so much, sir. We have another question. How to ensure longer shelf life of biostimulants for commercial purpose, especially cell-free extract, compromising of growth hormones, antibiotics, and vitamins?
Yeah, that's a good question. Yeah, I see biostimulants with shelf life issues all the time, so I'll touch on the microbial shelf life first. And my preferred way to extend the shelf life of microbial biostimulants is one, to utilize spore forming microbes. So a lot of the microbes like bacillus naturally form endospores and are very resistant to long storage periods. So I prefer to use spore forming microbes whenever possible. I also prefer to use products that have been freeze dried. That tends to harden them off and allow them to survive longer than the alternative of a liquid. On the other types of biostimulants, the non-living, um, I typically incorporate additives to the formulation, so different algicides and make sure that the pH level of the product is slightly acidic or is the correct level to ensure that it stores a long time. Also, making sure that it's stored at the right temperature, out of direct sunlight, and in an opaque container. All those things really help with shelf life.
Interesting. We have another
Thank you so
question.
much, Daksha, for this insightful lecture. I have one question. Which recent biostimulant innovation has shown the greatest improvement in crop yield or nutrient use efficiency under field conditions? Are you getting my point, sir?
Can you repeat the question? Do we
Yes,
see
yes, yes.
better?
I can repeat, sir. I can repeat,
Okay.
sir. Which
Yeah.
recent biostimulant innovation has shown the
Oh,
greatest improvement in crop yield or nutrient use efficiency under field condition?
yeah, that's a great question. There is a research paper in New Ag International, and oh, I can't remember. It would. I'll have to look it up, but this has been quantified, so I don't want to give you the wrong result. But it was either humic acid, amino acid, or seaweed extracts. But basically, they looked at thousands of papers. They did a meta-analysis of thousands of papers across the world and saw all of those three products improved yield by, I do know it's between 10 and 15%. So it was one of those three. I just can't remember which one.
Thank you. Thank you, sir. Thank you.
Oh, you're welcome.
We have another question. A farmer is using excessive NPK fertilizers, but the yield is still stagnant. So, how would you diagnose this issue scientifically?
Yeah. I mean, this would be the whole point of the presentation is we would first start with the soil test and then with the plant tissue test. And then we would start trying different biostimulants on the soil well, we look at the soil levels and the plant tissue levels. And if we see nutrients in the excessive levels in the plant tissue, we would tell the farmer to immediately, stop applying that fertilizer. We could also incorporate cover crops into the area because those could be a good way to immobilize the excessive nutrients. But I see it a lot of time where a farmer has over applied nitrogen and is under applying other beneficial nutrients like micronutrients, and that nitrogen might actually be blocking the plant's physiological processes because there's just too much nitrogen in that system. So we'll start to incorporate plant growth hormones and biostimulants to help with other yield limiting factors instead of just the nitrogen, phosphorus, and potassium.
Another question is, when we use biostimulants, which would be more effective, the soil drenching application or the foliar one? Also, are there any biostimulants that can control the bacterial blight?
Yes, good questions. Yeah, generally, generally the soil drench is more effective because plants have more access to nutrients and active ingredients through the roots than in foliar tissues. But what I always recommend to people is apply what is more actually possible. So, if I'm working with a farmer who has 1,000 acres, they might not be able to do a soil drench, so the foliar application is a better option. So both are very effective. The soil drench is typically more effective based on the research. Bacterial blight, yes, there are biopesticides that can upregulate genes in the plant and outcompete bacterial blight. I do know there is a Bacillus subtilis strain that is effective, a biopesticide that's effective against bacterial blight, and probably some other products I'm not aware of. So
Thank you.
what I would say about the biostimulants is they should be applied before as a preventative. They're more effective. And I'll also say that when biostimulants are combined with traditional chemical pesticides, they seem to work better in my professional experience.
Thank you, sir. And I believe we have our last question. Are there any negative impacts on plants when we use microbes for protection? Also, how can we use the microbes for dry seed coating?
Okay. Yes, there could be negative effects. Sometimes sometimes if we produce too much of a hormone, for example, if you applied, I mean, just theoretically, normally when I see microbes applied to a crop, we either get a beneficial response or a negative response. But there's always a chance that there might be some interaction, or maybe the microbial product, if it was a liquid, it went bad and you apply organic acids and it could burn the crop. But typically, I don't see negative effects of the biostimulant products. The main issue I see is that farmers are sold products that don't work or don't have something that's actually guaranteed in the package. But there's not really a big risk like accidentally over applying a pesticide. I've never seen a big risk of applying a biostimulant to a crop. Sorry, what was the second question?
Just a
Follow-up.
moment. How can
Dry
we
seed
use the
coating. Yep. Thank you. Dry seed coating, yes. So my company has developed a way to mix the microbial spores in a freeze-dried form with a dry carrier. So when the seed is in the seed box, we have the farmer sprinkle the carrier with the microbes on top of the seed. And then through electrostatic adhesion, the product sticks to the seed and is applied to the seed when it reaches the soil.
Thank you so much, sir. I believe that ends our Q&A session. So let's conclude. On behalf of the entire Krishi Navyug and Ankurin team, I extend our heartfelt gratitude to you, sir, for sharing your valuable time, expertise, and insights with us today. Your experiences in agriculture innovation, product development, soil science, and sustainable agriculture has truly been enlightening and inspiring. I would also like to express my sincere thanks to Dr. Pragriti Shivastava, founder of the Agriculture Valley Research Foundation, and Dr. Ankur, Chief Secretary of the Agri-Meat Bharat Foundation, for their vision and continuous efforts in making platforms like Krishi, Navyug, and Ankuran possible. Finally, a big thanks to all our participants for their active participation and engagement throughout the session. With that, we conclude today's session. Thank you all for joining us. Thank you once again, Mr. Lilly, for your time today. Have a wonderful evening ahead. Goodbye.
Thank you.
Thank you, Dr. Kaile and Dr. Pragati. Thank you so much.
Thank you, sir. Thank you.
Participants are welcome to leave the session now.